welcome Yusuf. Welcome to this session. Welcome Amud session. In the time we wait for participants to join, you can go through our social media platforms and share the link in the chat box.
Well, Shiv, your voice is a bit low. Will you please be a little louder?
Audible now correctly? Is it proper now?
No, no, it is still low.
Am I audible now clearly?
Yeah, it is clear, but little bit low. Okay, Yusuf mentioned that it is clear for him. So, okay, thanks, Yusuf.
Thank you so much, Yusuf.
तुझा टोपला खूप वाढलाय बरं. कबूतरही कन्फ्यूज होतात.
Chandrasekhar sir, your mic is on. We'll start the session in few minutes. Don't go anywhere. The time, social media platform. I'll also share our badge link. You can redeem the badges as well. Till the time we wait, you can redeem badges. Everyone. Start the session in 2 minutes. Chandrasekhar sir, am I audible clearly now?
Uh, yeah, Shubha, but I think your voice is still little low or better than earlier. But yes, you can go ahead now.
Okay, thank you. Hello and welcome everyone. I'm Shuk Parmar, your host for today's webinar. My team and I are here to make sure you have a seamless and engaging experience. If you have any questions or need assistance, feel free to use the chat window. We are here to help. So, the topic for today is machine learning with Azure ML from model training and deployment. About the ATC community, this webinar is hosted by the ATC community, a hub for enthusiasts passionate about cloud technologies, AI, machine learning, IoT, open source development, and DevOps. Today's event is sponsored by Synergetics. Synergetics is a leading edge learning solutions provider in India offering specialized training and consulting services. We empower businesses and professionals to thrive in today's fast evolving tech landscape by delivering transformative learning experiences. Our core focus is on enabling digital transformation through innovative skilling programs, advisory services, and end to end implementation support. From modernizing IT frameworks to mastering emerging technologies like AI, cloud computing, and DevOps, Synergetics is committed to equipping you with the tools and knowledge to succeed. Uh, these are the all 12 learning solutions which are offered by Synergetics, which you can see on the screen. This is the Microsoft certification skilling journey. The journey begins with the fundamental certification, then progresses to advanced role based certification, and finally to expert level certifications. We run communities on Meetup. This is the emerging technology community. Anyone who are eager to learn about technological knowledge can join this community on Meetup. We have multiple communities in Pune, Gujarat, Nagpur, and Indore. Those who are interested to join this community, please log in to Meetup app and gain your knowledge for free. We are thrilled to have Mr. Chandrasekhar Deshpande as our today's speaker. He is a certified Microsoft trainer and a consultant at Synergetics. He brings a wealth of knowledge and experience on AI and cloud technologies. So the agenda for this webinar will be participants will dive into Azure machine learning from end-to-end ML workflows, including data preparation, automated model training evaluation, and deployment as web services. The session includes MLOPs, best practices, and hands-on exercises like training a classification model and deploying it for real-time inference. This is the learning plan, which includes a one-day webinar, self-learning plan, mentoring and exam prep session, and knowledge assessment. As you all know, we provide a complimentary learning achievement badges, which includes an overview of the module topics which are related to this webinar. You can also share these badges on the social media platforms like your LinkedIn, Facebook, or X profile. To get the badge activated, you just need to follow certain steps and redeem the badges. You can see the steps on the screen, and I've already shared the link in the chat box for this badge. So please do redeem the badges. You have to follow the code of conduct, which will create a respectful environment for all the participants. Participants, please note you are not allowed to take screenshot of the presentation and cannot do screen recording. Thus, webinars you have been attending are designed to give you a brief overview and summary of the full course content. However, the HR certification training programs of this courses run over 4 days, and we are currently offering them at a special discounted rate exclusively for webinar attendees. On my screen, you can see the list of in-demand certification courses we are currently focusing on. Uh, so the start month will be the month of November. Please ignore the start month given on the screen. So for more details regarding these courses, I'll share contact to one of my colleague, Mr. Vivek Balasundaram. You can connect with him for more details regarding these courses. All right, everyone, it's time for a quick quiz to make our session a little more interactive and fun. We have 5 questions lined up, and each one will test your knowledge of today's topic. Don't worry, it's all about learning and just for fun. Think of this as a chance to check how much you have picked up. So quickly drop your answers in the chat box after every question. So here you go with the first question. Which of the following is the main purpose of Azure machine learning? I request everyone to please answer. Quickly drop your answers in the chat box. Quickly drop your answers. I request everyone to please answer. So yes, B is the right answer for this question. Building, training, and deploying machine learning models. We'll jump to the next question. All right, you guys have 10 seconds to answer the question. In Azure ML, what is an experiment? Is it A, B, C, or D? Quickly drop your answers in the chat box. I cannot see anyone answering. Let's see who knows better. Quickly drop your answers in the chat box. So the answer for this question is option C, a process that runs training scripts and tracks metrics. Jump to the next question. Which Azure ML component is responsible for deploying trained models as REST APIs? Is it A, B, C, or D? Quickly drop your answers in the chat box. The correct answer is option A, Azure Kubernetes Service. We'll jump to the next question. Well, what is the role of the compute instance in Azure Machine Learning Studio? Is it A, B, C, or D? Quickly drop your answers in the chat box. Request everyone to please answer. So B is the correct answer for this question, to act as a personal compute environment for training and testing. We'll jump to the last question now. Which of the following is used in Azure ML to automate model selection and hyperparameter tuning? This is the last question. Quickly drop your answers in the chat box. Yes, B is the correct answer for this question. AutoML, that means automated machine learning. So everyone, do follow us on our social media platforms to get relevant updates on upcoming webinars, workshops, and certification training we do. Thank you so much everyone for listening to me. Now we'll hand over the mic to a speaker, so you can take over from here.
Thanks, Shiv. So, I welcome all of you on this 2 hours marketing session on Azure ML services. I'm Chandrasekhar Deshpande. Shubha already introduced me. So, without wasting the time, would like to begin the session. So, I'm sharing my screen, and in the chat, Shubha has already shared a link. Let me share my screen first, and let me show you that link. So, here is that link. Okay, where uh, okay, it is asking you to go to the URL. Okay, this link you will also you can also search in Google. So I'm opening a web page for the link. So just a minute. Huh. Yeah. So what you can do is you can first of all open a Google, and in Google you can search for DP 100. DP 100 is the certification for data engineers and data scientists. And here you can see uh, the implementation of data science pipeline using Azure ML services. So here is that link. You have to go to Microsoft Learn website for a study material. I got a call from company. Give me a minute, please. Sorry for interruption. Huh. So here I hope everybody of you have gone to this link, okay, and you will land up yourself on this page, and here you will get complete self-study material on the topic of your today's discussion. Here you can attempt the model questions also. So you can view the videos also. Different videos are also available. Here we do run courses on similar topic. Okay, either it is a 1 day course or even uh, this is DP100. A 3 days course is also available for the same. Now, in this today's session, what I am planning to do is to introduce to you about a data science life cycle and a simple way to implement a data science life cycle without writing without writing a code. I mean to say we will follow two approaches: codeless approach and less code approach. Codeless means without writing any code, and less code means writing minimal code. And for this purpose, we will do uh, auto ML feature. We will exercise auto ML feature of Azure ML service. So first of all, let me quickly explain you the data science life cycle. Okay, and then we will see why do we need to say train the model, not only one model but multiple models to know which model is performing best and choosing the best performing model for the purpose of the deployment. So first of all, let me mention the steps here, okay, of uh, data science life cycle. So now, many of us perhaps are aware of the data science lifecycle. I did not have to go into much details. Okay, I could see you did answer most of the questions correctly. All those questions what Shubha displayed for you. So maybe just one or two of us not aware of the data science lifecycle. For them, let me quickly mention these steps. So the very first step is basically to uh, prepare the data. Just data preparation. Now here, first of all, what is machine learning? So machine learning basically is a process of training the model with the historical data so that model becomes capable of predicting futuristic figures, futuristic data. So that is a machine learning. So it can do prediction analysis. For that purpose, you have to first of all train the model on the historical data. Now, in order to train the model on the historical data, your historical data must be with a high quality. And data preparation takes care of improving the quality of the data. So in data preparation, you have to impute missing values, impute missing values. Okay, you have to say remove duplicates, remove outliers and duplicates. So many such steps you will have to follow to improve the quality of the data, and that is a step called as a data preparation. Then you have to do feature engineering. That is the next step, feature engineering. In feature engineering, basically you are making data ready for machine learning. Data preparation is a making data ready for general processing. But in feature engineering, now you will make your data ready for machine learning. So here in feature engineering, you may have to do normalization. You may have to uh, say identify dependent columns, identify label and feature columns. Okay. feature columns on which label columns are dependent. That's what you have to identify. So here you have to do feature engineering, and then comes training and testing of the data. So next step is training the data, training the model. Now here there are n number of machine learning algorithms available. These algorithms have already been written in specific languages, programming languages by uh, analyst. We don't have to understand what are all how those codes have been written. Okay, they already have written those codes for us. We simply have to take and use those models, and we have to submit data to these models. So data we will submit to these models. Okay, model. Okay, we will also submit hyperparameters to the models. Hyperparameters. Hyperparameters basically improve the performance of the model. So with the submission of these two things, we will train the model. Okay, and model performance changes with the change in the hyperparameter set. Now model performance changes with it. So you have to identify a model and a suitable hyperparameter set so that model gives you best performance. Once you identify the model which is giving you best performance, okay, then you may have to test the model. Okay, so actually in order to identify which model is giving you the best performance, so here we may have to do testing, test the model, okay, evaluate to find best performing model. Yes, that's what you will do. And once you identify a model which is best performing, that model can be deployed. So deploy a best performing model, deploy a best performing model on production environment. Production environment. Now, up till now, here we were using up till now here we were using development environment. Okay, training or development environment. Development environment. For development environment, we need larger environment for all these because your data is huge in size. The data, that's what you are preparing. Okay, you are training a number of models at the same time to get the performance of each model to identify or to choose out of so many models the best performing model, and then you will do a deployment of the model, and that you will do on the production environment. Just we saw one question, okay, on which environment do we, or on which service do we need, do we deploy that say model? And there the answer was Kubernetes services, AKS, Azure Kubernetes services, okay, or Docker environment. So there can be a number of environments where we can deploy the model, and thereby that model becomes accessible to the customer side. So customer side application may use that model to do different kinds of predictions. So these are the steps we will have to follow as a part of the data science life cycle. Okay, and here now first of all let me uh, yes, uh, let me close all these things and let me take you to some important topics. Explore and configure Azure AI machine learning workspace. Yeah. Explore machine learning workspace resources and assets. So what is the workspace? How do we create a different types of assets there? Okay. So there are, as far as data are concerned, there are data stores, data assets, the difference between data store and data asset. That also you can understand here. The material has been written really nicely and very easy to understand. So There are multiple components here. Okay, data store, data asset, environment, compute. Okay, so what do you mean by these different words? Okay, that what you will come to know here. Explore developers tools. Now whenever you are doing a development, obviously you will have to use a studio, or yes, Visual Studio or Jupyter Notebook for the same. Okay, so this lesson talks about using SDK for the development. Okay, how we can make the data available for Azure machine learning, what are all different ways available on Azure ML service for making the data available. Okay, working with a different compute targets, that also you can have a look at. What do you mean by environment? Okay, so now let me just quickly explain you about the compute target. Compute target basically is a cluster environment where you can do the development, or you can train and test your models. Okay, so here you can have compute instance for doing the development, compute cluster for uh, training the models, more than one models. So different types of computes are available there. I just took two names, but otherwise in total there are five computes available here. Okay, that also you can explore. Uh, so uh, compute instance for development purpose, compute cluster is for training and testing purpose. In case if you want to use other another cluster, the cluster of SD inside, cluster of data bricks, okay, for training and testing of the models, that is also possible. Then you can use serverless compute also for similar things. So how do we use serverless compute? So n number of computes have been explained here. Okay, mainly we will use a compute cluster for the purpose, uh, where two types of developments can be done. One is collaborative development, when one team of developers are working in the process of the development. Uh, okay, so there everybody have to get a sense, has to get a sense that the environment is working for himself or herself only. So that is possible in cluster development, compute cluster. So compute cluster allows me to do the collaborative development. Compute cluster allows me only to process very large size of the data. Okay, so there we will use a compute cluster, and in AutoML we will be using a compute cluster for the same. Working with the environments in Azure machine learning, so they are offering you different types of ready environments. Now, what do you mean by environment? So here in terms of Python, we have to install different libraries. Okay, so uh, whenever I want to work in Python, okay, I have to use n number of Python libraries, and there I have to pip install the different libraries, and the cluster on which, or a single instance on which I am installing those libraries. That becomes a kind of an environment for me, okay, to do the processing. This environment I can use, and in case if I want to share that environment to somebody else, okay, that is also possible, because similar environment deployers also have to create, okay, specifically when same model has to be deployed on the production environment. Okay, so here we have to create the environment, and environment represents the image of the execution environment, where in that execution environment different Python libraries have been installed. So it represents image. There are two types of environments available. One environment is of the curated environment, which environments have already been given by Azure ML service. These are ready environments which they are giving to us. Okay, so first of all, we will look into curated environments to know whether any of the curated environments meet our expectations and requirements. But in case if we do not get any curated environment, then we can create our own custom environment also. Okay, so environment concept is extremely important here. I am doing a little bit fast forward for the reason that these are all basic concepts, and I hope you are meeting all the prerequisites of this session. That's why I am not explaining you basic concepts, assuming all of you are aware about it. Okay, experiment with Azure machine learning, and here we will see find the best classification model with automated machine learning. Now, there are uh, two ways we can do the development. Okay, one way is rather there are three ways actually. There are three ways in doing a development here. Okay, so Azure ML service can be used to do development in three ways. The first way is Azure Auto ML. Now, in this way, you have to write minimal code. Okay, and what it does is AutoML feature of Azure machine learning service that creates a number of models for you. Okay, it calculates the performance of every model and it shows you these models in the descending order of their performances. So, best performing model is always shown at the top, and that model you can choose for the deployment. So, for all these models, you also can see their performances. You also can see there are different and different matrices, and you can do the comparison. Okay, and thereby you can select a best performing model. Here, this is completely codeless approach. Okay, codeless approach. Huh. And in case if you want to customize its hyperparameter tuning, then you have to write a minimum code also. So less code approach also. Less code approach. Both these approaches are possible here. Um, so customization of say hyperparameter is possible, but otherwise customization of complete training life cycle is not much possible here. Okay. In case if you want to get more leverage of customization, you can go with Azure ML Designer. Here, without writing a single line of code, you can do uh, you can train the models. Okay, UI based approach here. UI based approach. So you can use a designer also. And yes, designer also allows you some kind of customization. Okay, but in case if you want to have a critical customization and you want to do everything through Python SDK, then you have code based approach also. Okay, using language SDK. So I mentioned here Python SDK. Otherwise, you can use your other language SDKs also, and that way also by using tool like Visual Studio Code or Jupyter Notebook or Visual Studio. Uh, Using these tools, you can do this development. But for this development, you must be very good in Python development. In case if you are coming from a database background or in case if you do not want to write a code, okay, one of these two approaches you can select. So here in available time, I can take you through AutoML, and for that purpose, for designing end-to-end pipeline, okay, and do the deployment, we will go with AutoML. So I already have uh, logged into my Azure subscription. Now in this page, okay, I will take you through AutoML concepts quickly, and thereafter we will start with the lab. So pre-process data and configure featureization. So featureization basically means selecting highly dependent columns, okay, for training purpose. Okay, you may be having lot many columns in your data set, Okay, but not every column may be relevant in the prediction. So you may have to drop some of the columns and you may have to keep only those columns which contribute and participate in predicting label column value. Okay, so for that you have to do featureization. Featureization also helps in improving the performance of the prediction performance of the model by normalizing the numeric figures. Normalizing the numeric figures means all the figures are to be brought into same scale. Okay, age, for example, is in the range of age of the employee. Okay, it has to be in the range of 18 years to 60 years. Okay, but salary of the employee has to be in the range of you know $30,000, $25,000. So you see the variation in the scale. Their salary is in $30,000 scale and age is in two-digit scale. So here we have to apply featureization, or we call it the normalization, to bring these figures into similar scale. So that also improves the performance of the and accuracy of the model in prediction. Okay, here you will see how do you represent the data. Okay, so for that purpose you have to create ML table. ML table is a data representation. Okay, that enhances overall processing uh, speed. Okay, of training and working with the data. So ML table specifically. Okay, you might have seen data being represented in CSV format, in Parquet format, and here they are talking about ML table format. So data is represented in a tabular form. Okay, and here in ML table, okay, difference in between ML table and CSV format. CSV format is row major format. ML table is a column major format, which makes your data suitable for analytical processing. ML table represents data in column major format and thereby it makes data suitable for analytical processing. So here you have to represent the data in ML table format. Okay, here is some code what they are showing. Okay, understanding scaling and normalization. That's what I already have explained to you. Okay, now in featureization. Okay, your data automatically pushed into some quality improvement measures. You can choose to have AutoML apply pre-processing transformations, such as these transformations. It will apply on the data. Automatically, it will apply these transformations on the data. Okay, it will identify missing values in the data and accordingly will try to fill up those missing values by applying the different analytical processes. Categorical encoding also it will do. Categorical values are there. For example, small, medium, high. These are the words. Small is a word, medium is a word, high is a word. Okay, so small instead of being represented as a word, okay, it will represent it with a numeric value like 0. For medium, it may represent it by 1, or high, it may represent it by 2. So categorical values are also converted into numeric indicators. That also is a step necessary to see improvement in the performance of the model. Dropping high cardinality features such as record ID and primary key features of the data should be dropped here because they hardly contribute to the accurate prediction of the label column. Feature engineering. So these different operations are automatically applied on the data, and for this you don't have to write a Python code. Okay, so thereby it makes the data ready, and then it will run the automated machine learning experiment. Here it will run automated machine learning experiment. So automated machine learning experiment means it has to submit that data. Okay, pre-transformed, sorry, well transformed data to different types of algorithms to train the models. Okay, n number of algorithms are already available there. Okay, lots of algorithms are already available there. Ensembling algorithms are also available there. Okay, and it has to, you know, use, it has to collect every algorithm and create a model by training that model on the data. So that also process it will have to do automatically. In case if you want to restrict some algorithm, like if you do not want to use some algorithm, maybe it is very hardware extensive and you do not want to use that algorithm for training purpose. So you can restrict algorithm. You can decide which algorithm it should not at all select out of long list of the algorithm. That also you can do. Okay, and then you have to create auto ML experiment. Now this approach basically is a auto ML through coding. Okay, minimal code you have to write, but here you will see classification job is being generated and model is being trained. So that job gets triggered, initiated, and then it takes 3-4 minutes, 5 minutes, to create n number of models. And those models are also shown in the descending order of their performances. So it will clearly show you which model has best performance out of whatever models it has chosen. Okay, so there are multiple steps we will have to follow here, and I think it is a time for me to directly go to the Azure ML processing now. So here what I do, I go to, Acha, just a moment. Let me create an environment also. So in order to create an environment, here is a lab exercise what they are doing, giving to me. So let me follow here few of the steps. Okay, and thereby I will show you how can you develop auto ML and how can you get the job done using auto ML. So let me launch this exercise. Ah, yes, this exercise is asking me to go to Azure CLI, okay, and run these commands over there. Now here what we will be doing is there is a set.sh file they are giving. That file I have to download, and what that file does is it triggers ARM template to create Azure ML service related resources. ARM template to create Azure ML service related resources. Those resources I also can create using Portal. Okay, but normally on the floor, you will hardly use a Portal to create the resources. Okay, you will use ARM templates to create the resources. So here what I do, this is my subscription, and from here I can open Cloud Shell. Cloud Shell is an interface where I can get everything done through CLI commands. And in this Cloud Shell interface, okay, let me go to Bash Shell. So I am already inside a Bash Shell. I do not want to go to PowerShell. I am already inside Bash Shell. So let it open Bash Shell. Yes, and thereby I will give those commands one by one. Here, let me copy that command from here and submit it. Those commands here. The first command basically is to remove, delete a folder Azure ML Labs if it is already existing. So we will remove that folder and then we will download its recent version of that folder. So second command downloads from the Git repository the clones the new folder there. Okay, so here you can see Azure ML Labs folder has been created and all necessary things have been downloaded there. Yes. So now I have to go to that folder and some folder inside it and run setup.sh file. Okay, this file has steps to run ARM template to create Azure ML resources. I do not take you to Azure portal for showing these steps for the reason that all of you are aware of how can we create Azure ML service through portal. So here it is creating a resource group. It has created a resource group. Name of the resource group I can see here. Okay, RG-DP100 1357. Only first four digit. Let me remember. Okay, and now here it has started creating ML workspace. So ML workspace is area, storage area where all my artifacts will be preserved, and using that workspace, I can do every kind of development. Okay, we will launch the workspace, and there we will see how can we do multiple things of the development over there. So now here it is creating the workspace. So see what are all other artifacts it has created: log analytics workspace, application insight, storage account. Storage account obviously it needs because workspace holds all your assets. Okay, development assets, project assets. Okay, so all those assets are stored on the storage account. Key vault, in order to internally represent sensitive information, it uses key vault. And now it has started creating Azure ML workspace. Whatever here we are doing, okay, it is still not auto ML. It is simply creating resources. Okay, now here it is creating a compute instance. Okay, so now what I can do, let it create a compute instance and compute cluster. Okay, let me go to that resource group. Resource groups. I think I should search here. Resource groups. Yeah. And let me search a resource group RG-DP100. RG-DP100. Here it is. Resource group has been created. Let me go inside the resource group, and there I can see different resources what it has created. Okay, with the execution of the setup.sh file. So I'm going into workspace. Now here is the workspace. Other secondary and supportive services also have been created, which I am not interested in. Okay, because I want to go with a workspace for the development purpose. So I am going to the workspace, and hereby I will launch the workspace. From here, let me launch the workspace. Okay, so we have launched the workspace here. Now here to the left side, you will see authoring. All these four ways are of development. Okay, we can do a Python development using notebook, automated ML, designer. All these are available here. These are different assets as a part of exercising data science pipeline. These different assets are created. Okay, and compute. Now let me take you to the compute. And in compute, here you will see it has created. It is creating compute instance as of now. It is being created. Let me check with a compute cluster. Its creation is not yet started, but in setup.sh file, creation of these resources, commands to create these resources have already been written. So that's how it is creating. If I want to create a new compute instance, I can create it from here. If I want to create a new compute cluster, from here I can create it. Okay, so by using portal, all these things are possible. Here I can show you how it is creating the things using SH5. Okay, so that's all about compute. Here, if I take you to the data, okay, that SH file will also create data assets. We will see once that file completes the execution, we will see it will create a data assets also. If you want to create your own data asset from here, you can create, okay, of any kind of data that you want to use. Yes. So let me see here what are all things it has created. Now here, creating compute instance with a name. Okay, compute instance is still under creation. Rest of the things it has created. So we will have to wait for a while as it has to complete compute creation of the compute instance. In the meantime, let me take you to the compute and explain you different types of computes. Compute instance basically is for development purpose. Okay, you can use this compute instance to do the development in Visual Studio Code or in the Jupyter notebook. Okay, but basically it is for development. You can select CPU or GPU instances here. Okay, exactly which machine you want to use that you can declare here while creating the compute instance. If I click over here, okay, it is under creation, and that setup.sh file has given a command of creating the compute instance. Huh. Okay, and it is using CPU machine. But in case if you want to do deep learning, okay, there you can select a GPU machine. Also, if you want to do development in deep learning, you can use the hardware that you want to use. Uh, so it is still being uh, provisioned. It is still being provisioned. Let us talk about compute cluster. The compute cluster, okay, is a multi-node compute cluster for your training. It is a multi-node compute cluster for your training, batch inferencing or reinforcement learning workloads. So whenever you want to do development collaborative environment, or whenever you have a humongous size of data and that's what you want to process it, and for that you need a cluster, large cluster to quickly process that data. There also you can use compute clusters. Kubernetes cluster, okay, it is for production. Here you will deploy your model Kubernetes cluster, train or deploy the models with your self-managed Kubernetes cluster anywhere. Okay, so this is Kubernetes cluster normally used at the time of the production. Attached computes, here you can get HD Insight cluster. HD Insight is Hadoop cluster. Okay, Hortonworks cluster here you will get. Or if you have your own cluster of virtual machines, that is also possible. Or if you want to use a Databricks cluster, that is also possible. So in case if you want to hire the cluster from some other Azure services, that is possible. Serverless instances, these are serverless instances, which these instances you will get quickly, okay, within a fraction of a minute for you to do the processing. Okay, so serverless instances also can be used. Okay, so for any kind of ad hoc processing, serverless instances are normally used. Here, if you see, compute instance is up and running, and that setup.sh file has now given the command to create a compute cluster. So it will take some time to complete creation of the compute cluster. Okay, so looking at here, now it has started creating a compute cluster. Compute cluster, creation of the compute cluster. Okay, here it will not take much time because zero size means, okay, and then it will provision the cluster. It will create more nodes there, okay, as per your demand. So creating a training data. Now see, cluster has been created and now it has started creating the training data asset. So let it create. Okay, give me a minute. Okay, so it has created this data assets also. So compute has also been created, and see, as of now, it has created a cluster without any node. But this cluster, whenever you are submitting any workload to it, this cluster increases its size automatically. If you go to data, it has created data sets also. Diabetes training data set is something what we are planning to use. Okay, OJ training data set also you can think of using. As of now, here for AutoML, we will use diabetes training data set. Okay, so now here I already told you here. For the development purpose, you will use compute instance for the development purpose. So if you want to use Open Jupyter Lab, you can do that. If you want to use VS Code, that is also possible. Or if you want to open terminal, bash terminal on this node, so that is also possible. Okay, so here I am opening bash terminal on that node. It is a single node. Okay, and it's not a bash terminal, it's a Windows terminal what it has created. So no issue. And here, let me install necessary SDK libraries. Okay, so here I am pip uninstall Azure AI ML in case if there is any old library installed that we are uninstalling, and then we are installing recent version of that library. So it will start installing. This is the way you will also do the things in your local machine. You will give this command and will install necessary Python libraries. Yes. Now let me clone necessary Python code. On the floor, you will write these Python codes of your own. Here I will go with already written Python code. But I think Python code approach I will show you later. Okay, to go with, let me show you how can we do the similar things using automated ML without writing even a single line of code. So here I go, automated ML. New automated ML job. I have to create a new job by clicking over here. Yeah. So here we are creating a new job. It means all necessary configurations we will give to it, and then it will start job of creating n number of or training n number of models. Okay, so job name whatever it has given. Okay, experiment name, create a new one. We are creating this job for the first time. New experiment name, whatever it will select. Okay, default target, nothing I am supposed to configure here. Okay, going to the next. So here see the data that I want to submit for the training purpose, that also I will have to configure. The algorithm that we want it to use for training purpose, that also I will have to configure. Different featureization steps we may have to configure. Okay, that also we will do here, and thereafter then we will submit the job and it will start auto ML. Select the task type. Okay, so classification, regression, time series forecasting, natural language processing for deep learning, computer vision for deep learning. Here, I will show you the data also. Okay, but this is an example of classification. Now, let me explain you about this data. Okay, in this data, there are different parameters, pathological parameters given. And using those parameters, we want this model to predict whether a person, okay, is diabetic or not. Looking at those parameters, it will have to predict whether a person is diabetic or not. So yes or no, that is a class. That's why we will have to select the classification uh, type of algorithm. Okay, and here let me select. diabetes training data set. I will show you that data set. Okay, as of now, I am not able to open it. Let me do one thing. Let me show you that data set. Duplicate tab. Okay, let me take you to the data. Okay, diabetes training. Hmm, yeah, and explore. Here it will show me that data. What are all columns available? That also it will show me. Patient ID, pregnancies, plasma glucose, and a number of parameters are there. These are all pathological parameters. And the last parameter is diabetic. False means the person, the patient is not diabetic. True means yes, he or she is a diabetic. Okay. So this is the nature of the data. Okay. So that data I am submitting to it, clicking on the next. Next is task setting. Now we will configure other things, the algorithms to use and other things. Target column. The last column, diabetic, that is the target column. That is what we have to do the prediction of while giving initial data. Looking at the data, for a patient, we will submit these column values and it will tell me the prediction of the last column. Okay, this is what it will behave in the production. In production, we will submit all these values. These values, what we will submit it, which will support it for prediction. These values are called as a feature values, and the value that what it predicts, that is called as a label value. Okay, so label value is a diabetic last column, and feature values are initial columns. Okay, so feature values and label values. So label value is a target column. So that's what I have selected here. I I do not want to go with the deep learning. Okay, deep learning normally is for too many complex situations, natural language processing and image analysis. So here I do not want to go with. I want to go with machine learning. View additional configuration settings. So let me click over here. Okay, what is the primary matrix? Say in classification, these different matrices of performance are available. AUC weighted, accuracy, recall values, average precision, okay, and others. So let me go with the accuracy here. So accuracy is one of the most selected performance evaluation value. That's why I will go with it. Okay, explain best module, enable ensemble stacking. Okay, let me not select it. Ensemble stacking means more than one models may be used together. So more than one model create their ensemble, one group, and all of them together do the prediction. They do not do individual predictions. All of them together they do prediction, and thereby, whenever multiple models do predictions, that kind of ensembling design gives you better performance. Use all supported models, blocked models. So let me decide which models I do not want to go with. So SGD maybe okay, multinomial naive base. Let me go with Bernoulli. Let me not select KNN. Let me not select. So I'm randomly deciding which models not to select, but on the floor, perhaps there will be a reason for not selecting some of the models just to cite you the decision tree, KNN. They are in say resource intensive algorithm. That's why I am dropping them. Random forest is also resource intensive, but random forest normally gives me better performance. So I am going with it. Okay, extreme random trees I am unselecting, gradient boosting unselecting, linear SVM unselecting. Okay, so some of the algorithms I am keeping there, and some of the algorithms I am deciding to block there. So furthermore, with that selection, now let me click on save. Okay, and thereby I have configured what algorithm should it select. Okay, for training purpose. View featureization settings. I've already told you that featureization means Normalization, featureization means deciding the dimension. Dimension decision means which columns should be selected for training the model and which columns it will have to go decide to go with in the prediction also. Okay, so it will apply its own logic for the similar purpose. Okay, so it will apply. So here by default, featureization has been enabled. Okay, and on these columns, now here you can see range of the values. Okay, pregnancy yes or no, the value ranges in single digit. Plasma glucose value ranges in 2 to 3 digits. Okay, so in order to bring all the values in the same scale, it will have to apply some normalization techniques. Okay, so it will apply it. I'm clicking on save. Yeah. Some of the limits, if you want to put, you can. I will go with the default limits, whatever it has. Okay. Validation and testing. Here now there are different ways of validations and testing. K-fold cross validation, train validation, train and split. Okay, so train validation split I will go with. Normally you prefer K-fold cross validation to avoid what we call it as the overfitting of the data, but it takes a longer time. That's why I select train validation split. Okay, and in train validation split, okay, percentage validation of data. Let me mention here percentage validation of data. Recommend between 30%. So here, okay, let me mention 30%. So 30% of the data. Okay, here I already have shown you the data. Out of there are first 50 rows it is showing. In case if there are 100 rows, 30 rows out of 100 rows it will extract and keep separate for the testing purpose, and 70 rows it will use for the training purpose, model training purpose. Okay, so 30 to 70% here I am selecting 70% rows for training purpose and remaining 30% rows for testing purpose. Okay, clicking on the next. Yes, and which compute to use. So here I will go with compute cluster, AML cluster, which already has been provisioned. Okay, so that AML cluster I will ask it to use. And then when I click on next, it will give me or it will show me final configuration and then submit training job. And now let it start the training. Huh? Okay. In the meantime, if you have any questions, please go ahead. Let me just verify once which heading. Okay. Could you please share the first link that you showed? Here it is. Okay. So now see, if you try to do all these things in Python, you will have to write Python code for data cleaning, missing value imputation, and all other things. For every step, you will have to write a Python code. For featureization, you will have to write a Python code. Okay, and then for creating a training the different and different models, again you will have to write a Python code. Extensive Python code you will have to write. But here in Azure ML, you will see without writing the code as of now, I am able to initiate auto ML. Yes, so as of now, it is creating run, and thereafter it will start training the models. Okay, it has picked up diabetes training data set. Okay, and now it is going to take a little bit more time. Okay, for the purpose of making the models ready. In the meantime, in case if you want to have a 5 minute break, I think it is a good time to take a break. So uh, I will go on the mute for next 5 minutes. Let us take a 5 minutes break. Okay. In the meantime, it will keep running. Okay. Let it continue. Whenever we will come back from the break, we will see some more progress here in this step. Okay. So I think it is a time for us to take a break. It's almost 4:40. Let us resume our session by 4:45. Okay. Small break. Let's resume by 4:45. I will go on the mute. So I am back, and now it is setting up the run. Okay, it is yet to come to train the models. Okay, it is simply creating an environment. Okay, for data preparation purpose, for featureization, and for training the models. Okay, so if you go to compute from here, now let me go to this tab to go to compute. Okay, internally it is using compute cluster for the same, and here you will see, earlier, if you recall, the size of that cluster was of 0 nodes, but now it has become 1 node because it has provisioned 1 node there for the purpose of the processing, and there this processing is going on. Okay, so featureization is happening on that single uh, compute cluster node. Once it completes the featureization, thereafter then it will start training the models. Guardrails. See, in data preparation, class balancing detection, it did class balancing detection. Class balancing detection means it should not have more records of a particular class and very few records of another class. So somewhere your inputs were analyzed and all classes are balanced in your training data. Okay, missing feature values imputation, no feature value missing values detected. Okay, but otherwise, in case if it detects such things, it will definitely highlight those things for you to know that your data needs quality improvement. Okay, high cardinality feature, so it has identified column if any with a high cardinality. Okay, so here it takes your data through a couple of steps, okay, to know, to let you know what kind of steps you may have to apply to improve the quality of the data. Okay, as of now, it hasn't started yet of training the models. Okay, now it has started model training. Okay, and there for every model training, it is going to create a separate job. So these are the different jobs what it is creating. For every model training, a separate job it is creating. Okay, if I go to model, now see, first model is being trained. Okay, accuracy is not yet identified. It will identify the accuracy, and that figure also you will see here. But yes, it has started creating the models one by one, evaluating their accuracies, and arranging these models in the descending order of their accuracy. At the same time, let me do another thing also. Let me go to compute. Okay, here in compute instance, and let me open terminal here. Let me open terminal here so that I can show you how to write a Python code in creating auto ML. So let me open terminal. Yeah, and my lab steps are asking me to run this code. To run this code, I think I did open terminal. No, yes, yes. It will uninstall uh, SDK of old version and install a new SDK of new version. Next step is to clone Python code. So Python code is also cloned. Okay, and then this ready Python file, what it is giving to me, that I will have to open. Refresh. Labs. Here is that file, Python code file. In the meantime, let me go back there and see progress there. Let me refresh it and let me see how many models it has created by this time. So I can see many models it has created, and all these models are giving 100% performance. Okay, so all these models are no, sorry, accuracy. Here is accuracy 95%, 95%, 94%. So as of now, till to this time, this model is giving me best performance. For every model training here, it is giving you a new job. Okay, and many jobs are still remaining. So let me wait for it to. Yes. Here, if you see this code, how do we connect this particular notebook to the workspace? How can I get a reference to the workspace here? That is the Python code to get a reference to the workspace. Okay, then we will submit to, and here we will get a reference to the workspace. Okay, then these are the steps to get a reference to the data. So here is I am submitting the name and version of the data set. Okay, and here I will get a reference to the data. And then here I have to configure, okay, automated machine learning job. Here I have to configure. So I am asking it auto ML classification job, name of the cluster mentioned here, experiment name, it can be anything, training data, reference to the training data, target column name, okay, primary matrix, accuracy matrix is being mentioned. And cross validation, I told you on in production, training testing split, instead of using training testing split, and cross validation is preferred as it avoids overfitting of the data. Model and say explainability true. Then here we are submitting some limits also, and thereby here we have configured the code, we have written the code, and here we will trigger the execution of auto ML. As of now, one auto ML is already going. Okay, it's already working there. So I think there are two things running. So it means it may have two nodes. It may have created a cluster of two nodes because these two things are running in parallel. That's why. Okay, so multiple algorithms it will apply, and thereby it will give you a best performing model. So till to this time, max ABS scalar is an algorithm to apply normalization, and XGBoost classifier is a ensemble algorithm what it is applying. And both of them, I mean, it's a normalization technique and algorithm, both of them, makes a production model. So in case if you have done uh, data science using your old techniques, using Python, how painful it is, everybody knows. And see how this auto ML has made all these things damn simple. It has made say, data science process damn simple. Going here, okay. Yes, just few steps are remaining now. Back to models and child jobs. Okay, see these many models it has created. So logistic regression, random forest, and their performance is not highest or best. Okay, light GBM, you can see performance there. Child jobs, last two jobs are remaining, and thereafter the best performing model. Okay, we will have to deploy. Going to overview page. In overview page here again, it is still training the model. Okay, it is yet to declare best model because last two jobs are still under processing. Class task type, it is a classification. Featureization has already been enabled. Primary matrix is accuracy. Yes, that whole information is appearing here. So it looks like it has completed. Okay, let me go to models. Still, this seems to be best performing model. Okay, on the overview page is yet to come to know which model is best performing because it has to show the name of best performing model here at this place. So let's wait for a while for it to complete overall processing. From here, you can compare multiple models, okay, on different and different matrices. Here you can register the model to registration service. Still close. It is actually in the process of closure of all the things. Otherwise, it has identified the models, I believe. It has identified the models. Standard scalar wrapper, logistic regression. This is the worst performing model. It created any new job here? No, no new job it created. Okay, so it is about to wrap up the things. So let us wait for it to complete wrapping up. This best performing model, okay, this is the best performing model. And if you want to deploy this model, or if you decide to deploy this model, you can click over there. These are details about that model. If you want to view hyperparameters on on which hyperparameter that model has been trained. Okay, that also you can see. And if you want to deploy that model, from here you can deploy. Now remember, whenever you deploy this model, okay, it will be deployed on Kubernetes environment. It gets deployed on Kubernetes environment. So real-time endpoint. Okay, so let me click over there. And here, in the production environment, how many nodes do you want? Okay, that is mentioned. So let me have, 3 nodes there. Okay, yeah, this is a machine good to go with. Not enough quota available. So let me make here 2. Okay, for 2 also it's not. Let me just see. Any other model do I select? 16 core. Can I select 16 core model? You do not have enough quota for following. Okay, let me select one instance only. Okay, fine. For this machine only, I think I have enough quota. So let me go with that. New endpoint, endpoint name, and yes, now I can start deploying the model. So maybe machine is too small to go with, but I don't have enough quota for other models. You do not have enough quota for following VMs. Let me select this one. Too small. Okay, fine. So let me go with this because I am not able to select any other model here because of the quota issue. 16 core. Okay, let me go with it. Clicking on deployment, and it has to start the deployment. The size of this machine is too small to get this model deployed. Okay, but as I am lacking in the quota, that's why I am selecting it. Termination due to insufficient memory. Let us see. Let us keep our fingers crossed and hope it will complete the deployment of single instance only. Yeah. Again, it is going to take a longer time for the deployment. Model deployment is successfully triggered. Okay, so it has started the deployment, and the progress of the deployment I can see in the endpoint. Here, when I click, okay, here is the model deployment. Real-time endpoint models. Uh, who is this model? Real-time endpoint. Okay, no, it has started deployment. I should see it in endpoint. Yeah. Here. Now it is still provisioning. It is going to take a longer time for provisioning, but once that model is deployed, it will be deployed in the Kubernetes cluster. Okay, and thereafter we can use it for production purpose. So from Python application, data, uh, feature data can be submitted in the form of the JSON to this model. Okay, we will see the REST endpoint for this model. Okay, using that REST endpoint, from the Python code, we can send a JSON data to this model, and in response, this model will show us the prediction. It is going to take next say 10 minutes. Provisioning state. Okay, provisioning state. Endpoint for endpoint provisioning state is done, but for deployment now it is doing a deployment. It will take a longer time. In the meantime, if you have some questions, please go ahead because this tape will take a longer time, maybe 10 minutes, 15 minutes. What is the difference between automated ML and designer? In designer, you can try one or two models, three, four models also, but there you have to design, you have to create a designer pipeline. Okay, you will have to create a step to ingest the data. Then you will have to create another step to apply different data processing, data transformation steps there. Okay, here we are already using transformed data. There we have to add in designer we have to add steps. Means see difference. First of all, let me give you difference between designer and Python SDK. In Python SDK, for every step you have to write a Python code. In designer, for every step you have to simply drag and drop that step, okay, onto the canvas. Whenever you drag and drop that step onto the canvas, down the line it writes the code automatically. So in both these cases, code is written for every step. In Python SDK, that code you write. In designer, that UI writes the code for you. Okay, so uh, that is difference between Python SDK and designer. In AutoML, you don't have to, either select the steps or write the step every step. You simply configure it, and now it is doing everything of its own. You simply have configured it, and now it is doing everything of its own. That is the difference. So automated ML, why we call it as automated ML? Because it is really automated in the sense that you simply have to configure it, and that's all. Simply have to configure it. Okay, still it is taking the time, and let me see whether I can refresh this. Still under provisioning. Still under provisioning. Okay, so that is the first question what I got, and let me know. Have I explained this question? Have I answered this question? So whenever you want to do with a less code approach, codeless approach, you will go with AutoML. If you want to comparison as per the time, AutoML can be, we can design 50 models. We can train 50 models to choose a best out of, within an hour or so. AutoML saves us our lots of time. In designer, you will need at least 3-4 hours to design the complete designer pipeline. And in Python SDK, it will take at least a say 5 hours maybe to design a complex Python code. So that is comparison on the basis of time taken. Now let us do a comparison on the basis of customization. In AutoML, you do not have much scope for customization. In Designer, you have moderate scope of customization. And in Python, you have very high scope of customization. So wherever you need critical customization, you will always prefer going with Python SDK. Hello, Siddesh. Have I made that point clear? Anybody has any question, please go ahead. Anybody has any other question, please go ahead. As it is taking a longer time for preparing the model and for deploying the models. Shubha has shared a feedback link. Okay, before you leave the terminal, humble request to submit the feedback form. Feedbacks are extremely important for us. Okay, so without fail, please fill up the feedback. It is still provisioning. Once it completes the provisioning, there I can see the REST links. I can see the Python code, which I may have to embed in my application to interact with this model for the purpose of the prediction. I can see a testing window also. Okay, so thereby I can test the model also, but this is the step of uh, say deployment now. So on the Kubernetes environment, it is deploying the model. So this model, if it's a Python model, okay, the best performing model, what we have got, if it is a Python model, in the production environment, in the Kubernetes environment, only deploying the model is not sufficient. It has to create a Python environment there. This model uses scikit-learn library. So in the production, it has to install scikit-learn library also. Scikit-learn, not scikit, sorry. Scikit-learn library also. It has to install that library there. Let me check. Have I received any question? Please go ahead with your questions. It is still provisioning the environment. And I believe it is going to take next 10 minutes to provision the environment. Okay, so we will run short of question answer session. Okay, and that's why better we trigger question answer session right away. But yes, within 2 hour session, here I could show you training of around 30 different models and choosing the best performing model. This job has been made damn simple. This is the job of data scientist, which has been made damn simple by using auto ML. Otherwise, data scientists may need uh, many hours to do the same job. So in our DP100 training, we train or we explain you designer approach, auto ML approach, as well as Python development. We cover everything there. All these three approaches we cover there. There is something called as a ML flow. Okay, to orchestrate say training and testing pipeline. So how can we use a ML flow? that also we cover there, and it seems it is completed. Provisioning state completed, and now I can see here test consume. Okay, so let me take you to the consume first. Okay, so REST endpoint is appearing, authentication keys are appearing, and here is the Python code. Okay, here is the Python code. This Python code you will have to embed within your Python application to get the prediction from the model. So this is the Python code. Okay, the key, API key. Here you have to mention this API key. I did show you API key just now. Here is primary key or secondary key. One of the keys you will have to copy paste here. Okay, and thereafter this code will run as it is. You will have to submit a data. Data you will have to submit here. In this JSON, you will have to submit the data, and thereby you can get the prediction here. Here you will get the prediction. So code is very simple. Okay, for programming language to consume the prediction. This is one UI available. Here also I can try submitting some data. Okay, I will have to submit the data here. Okay, within these braces, and then click on the test. Okay, it will show me the prediction. It shows me the prediction. So on this page, you will see testing web page also. You will see that they are giving you ready-made code, which you can just copy paste within your application and get the predictions done. It allows me C Sharp, Python, and JavaScript like language to use the REST endpoint. So that's how AutoML works. Okay, I also did show you same thing can be done through notebook here. Huh, yeah. So here we open that notebook labs 06. And I did show you those steps also. When I put that notebook to run, okay, when I put that notebook to run, these steps are executed one by one. Okay. Here I may, if I want to add some more steps, Python steps to prepare the data, I can add and I can prepare the data. Here we are creating classification job, configuring classification job. Okay, and this is the code to start automated machine learning job. Now you may ask me the question that here also we are supposed to write the Python code. Okay, while using Python SDK, there also we have to write a Python code. But yes, here we are simply writing just few of the code lines, not more than 15, 20 at the most. But if you use a Python SDK for similar things, there you will have to write at least 200 lines, in between 200 to 400 lines for doing the same thing. There, this AutoML makes a difference. Whenever you are triggering that job, AutoML job, it may take an hour or so to complete all the training of the models and identifying the best performing model. It will take hour or so. This single step takes an hour or so for the execution. So here I did explain you some of the basic concepts. Okay, and I did demonstrate to you the AutoML. So through the AutoML, I did take you through the steps of the data science. Okay, and how this AutoML can make these steps possible easily. Okay, so the last step now I am supposed to do is to clean all resources before I leave the terminal. The compute resources are cost intensive. So I have to delete, first of all, I have to delete compute instances. So here is one instance. Let me delete this is compute instance. Let me delete it. But before I delete, let me again wait for next 2 minutes for you to put forth any question, because once I delete it, then it will be difficult for me to explain the things. We'll wait for next 2 minutes for you to put the questions. Okay, so questions, please. Seems there is no question. So let me delete compute instance now. Thereafter, let me delete compute cluster. Okay, so here I am deleting compute cluster. Yes. Any other instance, if it has opened, there is no Kubernetes. I did not attach any compute. There is no serverless instance also. Okay. It will take next 2-3 minutes for deleting this compute cluster. Okay, but otherwise I have deleted compute. Now it is time for me to delete all resources. Okay, so I am already inside. I have to go to this resource group, which we created at the beginning of our session by running setup.sh file. Okay, and let me delete this resource group. Let me delete this whole resource group. Resource group name I am copying to clipboard and pasting it here. And let me click on delete. See, so many resources it did create. Azure machine learning was an online endpoint. Many resources it did create. And now I have put them for the deletion. It will delete things one by one. Please fill up the feedback before you leave the terminal. Okay, and I am here till time ends. Okay, so you can put your questions also. Okay, I was telling you about DP100. In the DP100, they also have introduced a module on generative AI. On generative AI. Okay, how can we integrate Azure AI service with the generative AI? Okay, Foundry portal. That module is also there. Deep learning module is also there. How can we use deep learning in Azure AI service? That module is also there. Okay, but in 3 days we cover all these topics really extensively. Okay, with 60 to 70% hands-on, around 80% hands-on, I will say, because for me, I conduct the hands-on, and through the hands-on, I explain the concept. Okay, so I spend separate time for some hands-on, sorry, separate time for some concept which I cannot explain through code, but otherwise, most of the concept I try to explain through the code only. So thereby, you can relate the concept to the code, okay, and which will be a good learning for everybody. Okay, but we provide a subscription, we provide hands-on in our 3 days training, and we make you ready for role of a data scientist. So that's all from my side. If you want to drop from the meeting, you can, but humble request to fill up the feedback form. And that's all for today.
Everyone, please do fill the feedback form before ending this session and do redeem your learning achievement badges as well.
So thanks all for attending this session. Best luck for exploring this new technology, and have a nice day.
Thank you so much, everyone, once again for attending this session. I hope everyone enjoyed it and gained something valuable. So please do fill the feedback form before ending the session. It's a humble request. Once you are done, you can end the session. Have a happy weekend, everyone. Thank you.